Hi everyone, I am Oscar Bonastre, the chair of IEEE Education chapter at IEEE Spain Sector. Also, I am the chair of the IEEE Spain Sector. The main goal of this message is to introduce the webinar series Internet of Things and New Frontiers in Education. This event is organized by the Spain, Portugal and Bangalore chapters of the IEEE Education Societies. In collaboration with the IEEE student branch of the UNED, the IEEE ETA Alpha chapter of the UNED also, the Spanish section from IEEE, the Portuguese Society for Engineering Education and the Revive University. Let me introduce the scope of this event. Firstly, every day the devices connected to the networks are increased. New applications arise for this type of interconnected objects, thus offering new alternatives for solutions of any kind through the use of technology. This is why this event is inspired by these new technologies for its application in the educational field, with the purpose of contributing to the use of IoT as a tool in the classroom. The format of the event will be of 5 webinars as follows. The first webinar will be Education and Remote Laboratories, and the speaker will be Manuel Castro. The second webinar will be IoT and the Practical Laboratories, with the speaker Sergio Martin. The third, Security Devices and Education, and the speaker Elio San Cristobal. 4. FPGAs and Remote Educational Activities. The speaker Pedro Plaza. 5th, FPGAs and Remote Laboratories. The speaker will be Alejandro Mancho. I want to thank also the valuable effort of the colleagues Rajapur Sivaridi from Bangalore chapter and Manuel Castro of the Spanish chapter. Their contributions have been important for the organization of this event. Finally, I hope this event will serve to bring our communities closer and exchange experiences. Thank you.
Yeah, at the outset, I would like to thank the IEEE Education Society Spain Education Chapter for giving us an opportunity to share knowledge and network amongst the two countries, that is Spain and India, and in particular between the IEEE Education chapters. I would also like to thank Professor Manuel Castro when I wrote a mail for the first time and requested Professor Manuel Castro to give a webinar in IoT and New Frontiers of Education. He was so gracious and told me that instead of having one webinar which will not serve much purpose, let us have a webinar series wherein we'll have talks on 5 days, and that's how we connected each other and set out to roll this particular webinar series in the month of January. I thank Professor Manuel Castro for his great giving us an opportunity to network amongst these two countries. IEEE Bangalore section in particular is a very vibrant section in Region 10. I would like to place on record that we have reached 10,000 IEEE members, which is a record for our country, and we are number 1 in our country, and in Region 10 we are number 2. We have more than 15 societies which are very active in IEEE Bangalore section. IEEE Education Society Bangalore chapter is a new chapter which was inaugurated on November 1st, 2020, and since then we have planned to have some educational activities. We are around 46 member strong team. We have a couple of students and number of members. Most of the members are from teaching community. So with this background, I would like to again thank Professor Manuel Castro, who is a fellow of IEEE, a full professor in electronics technology at the Electrical and Computer Engineering Department of Spanish University for Distance Education. A brief introduction to Dr. Manuel Castro. He belongs to the organizing committee of the IEEE Educon Chair, the IEEE Edu9 and SAAEI conferences. He is a member of the board of directors, BOD, of the IEEE. He was a recipient of the Extraordinary Doctoral Award from the UPM and the 1988 Visgo Doctoral Thesis Award for improving scientific research on industrial process electricity application. He has been world renowned with several awards, being the most recent 2019 IEEE William E. Saleh Award for Achievement in Education of the IEEE Education Society. With this brief introduction, I would request Professor Manuel Castro to begin his talk for the day. The stage is yours, Professor Manuel Castro.
Hello, Siva. Thank you very much for the introduction, and thank you to be here for all the people that is in this first webinar of the webinar series on IoT and new frontiers in education. It's a pleasure to be here. I'm Manuel Castro. I form part of the Spanish chapter of the IEEE Education Society. I am, as Siva said, President Emeritus of the IEEE Education Society. And today, Oscar Bonaste cannot be here because he's making examinations face-to-face. And I will introduce a little bit of his work, putting a video that you can see it inside this part. After the video, I will continue with the presentation of the series. Thank you, Oscar, for your presentation. And we will continue with the starting of this webinar series of this week series there. We have 5 different videos and 5 different webinars. Today is the first one. I will do the first one about education and remote laboratories as part of the IoT and new frontiers in education. Tomorrow, my colleague of the department, Sergio Martin, associate professor of the department, will talk about IoT and practical laboratories, making some experience of the last 4 years about different European projects. On Wednesday, Elio San Cristobal, another faculty of my department and associate professor, will talk about security, devices, and education. That should be part of this webinar too. And later on the 21st, on the Thursday, Pedro Plaza will talk about FPGAs and remote educational activities. Pedro Plaza is the current chair or president of the IEEE UNED student branch. And the last one on the Friday, on the 22nd of January, Alejandro Macho will talk about FPAAs and remote lab. FPAAs is the analog version of FPGA, and Alejandro is the chair and the president of the IEEE UNED ETA Kapanu chapter. This will be all the week. Thank you for the collaboration, Siva, and it's a real pleasure to have people mainly from the chapter in Bangalore. I will have people from the chapter in Portugal. Pedro Fonseca is here connected too. And we have people from the United States, for the IEEE Education Society. The past president, Junior Russ Meyer, is connected from Milwaukee. And the president-elect of the society, Martin Llamas, is connected too from the Vigo University. And we have a lot of people connected in this moment there. Well, I will start with the presentation. It's a real pleasure to have it here. I will talk a little bit about education and about remote laboratories, as I told you before. First one, when we are talking about education and we are talking about the combination of the education actors that we have in online and distance learning, there is a lot of people involved there. When we have a typical face-to-face of traditional education, we have a teacher, we have the students. They are the two important parts, the two roles that we have in this education activity there. Sometimes we have different teachers, or associate or assistant teachers on the labs, but this is the major part of the people involved, and some administrators too for the general use of the education. But when we are talking about online and distance learning, we have a lot of people involved there. We have administrators of the platforms that we have today with the WebEx. We can have a learning management system, that is the platform to use it there. We have instructional designers that will design all the contents of the courses and all the specific activities, educational activities that will have to be involved there. We have material designers to develop the best materials for these courses. We have curators to check all the materials and all the things that we'll put in the design and inside the platform. We have, of course, the teachers, the tutors, and animators that will do the day-to-day activities inside the educational course. And of course, we have the students. The students are the main part, the more important part of the education. And in this case, the students are part of the educational activities there. But we have too some other peer students that we collaborate in the collaborative environment in online. It's really important, the collaborative environment. And of course, we have senior students that can do some kind of assessment and some kind of support of the younger students there. And of course, when we are talking about this kind of educations, we're going from the teacher-centered education, from 10 hours of teacher is a credit, to a more student-centered education that we have now in the higher educational space in Europe and in some other parts of the world. We talk about European credit transfer systems, ECTS, where 25 to 30 hours of a student is the credit of education. And around the teachers and around the students are the profession and the family, because normally they used to have in the online and distance learning, the typical students are not young students. They used to be from 30 to 65 or 70 years old students. They used to have childs, they used to have parents at home there, and there is all this kind of family, and they used to work too. Then all these things together are the environment of the activities of the online and distance education. And for all these kind of things, we have to be in mind the way of the knowledge acquisition we have. This is really old, from the 90s, in the last century, the learning paradigm from William Glasner. It was a psychology there, and he established that in the typical face-to-face traditional education, from 5 to 10% is typical remainder for the students there. When we are talking with the more recent education activities like the MOOCs, the video-based education, we can go until the 30-40% of retention of these kind of things. When we talk about the blended learning, when we talk about the combination of face-to-face, magistral classes, and we talk about the online environments and collaborative work, we can have around 30 to 50% of the remaining and the retaining things. And in the major increasing of the major part of the knowledge acquisition with the modern techniques like the PBL, of course, the project or problem-based learning, and of course the labs in the different activities there, the labs from the hands-on labs or the labs for the activities you can have in the remote labs we will see later on. We present in this case the redesign of the teaching and learning cycle we do in engineering in my university. In my university, we have the first roadmap for the young students in the freshmen. They go to theory, practical, exercises, grading, and real labs. We try to avoid all the kind of simulations, virtual or remote labs, because the students in the freshman time, they didn't have the sensation of the difference between a real lab and a virtual or a different software lab, in this case on simulation. And it's better to have a really good background. When we pass this kind of first semester in electronics or electrical engineering, we can go for the sophomore or juniors or seniors. We'll talk about theory, practical contents, go to simulation really early, virtual labs, remote labs, grading, and finally we can go again to the pocket labs to have some things at home and real labs again. This is the redesigning of the teaching and learning cycle we do in my university there. And we are using for the last 40 years when we started to work with the simulations, starting simulation with the Spicy and starting with labs. Of course, the good thing is that the future is here. We are in a ubiquitous and technology world. We can have all this kind of remote simulation system software from any place, anywhere, any moment, any device, any content, any connection, any competence. We can do this kind of things working together for all this kind of things there. And of course, if we will see the evolution laboratory, we can see that we started with a typical hands-on lab, making traditional on-site at distance, in this case for the people, and they came from the labs and they do typical with instrumentations like oscilloscope, generators, wave generators, or DC generators, ohmmeters, and so on there, and the typical board for the electronics things. And after this typical hands-on lab, we are starting with all simulations like SPICE in the beginning of the 80s, 90s, in the last century. We're talking a typical black window, putting together only the characters curves there. Now we are talking today about the new simulators, new graphic user interface, like the new SPICEs, new ORCAD, or new versions of new systems like electronic workbench or so on. And we are in the last years doing a lot of efforts in the development of virtual and software labs. The major part of the thing is we have to bring to our students the difference between the real components, simulations, virtual and software labs, and of course, the remote labs. The remote labs is a real lab that you can share through internet, and in this case, you can put all the information in the internet world working with the people there. Those are real components. They have a real characteristics. They are not virtual or ideal characteristics there. They are not resistance of 1000 ohms. They are typical resistance for 220, 470, the typical values we have in the real environment there. And you can use in these cases typical systems like VSIR, for example. This is a multiplexing users, it's a multiple user electronic systems. We have VSIR systems today in several parts of the world, in Spain, in Portugal, Austria, Sweden, Argentina, Brazil, United States. We have 10 or 12 different VSIR systems working in the world, and we have a lot of effort developing in this side. We have the typical systems for LBIS in the National Instrument Systems there, or we can have, for example, FPGA remote lab or a robot arm where you can download your system and you can have experiments with a real remote arm in the remote work. And of course, when we try to approach to this kind of remote labs or the labs to the students, and at the beginning of the time they start to start in this kind of pocket labs 5 or 6 years ago, because you have Arduinos, we have Raspberry Pis, we have a lot of electronic components, control components that have a lot of calculation power, and you can do some Lego activities or something there. But we started really these pocket labs 50 years ago. We started in the 70s, in the 80s in my university. We have a patent in this time there, and we develop a briefcase where we can send to the student, and the students have at home all the labs they can do in a typical electronics, analog and digital electronics in our laboratories there. We have two sizes, one small briefcase, one large briefcase with different components. Normally analog and device and digital devices was in the small one, and power electronics was in the big one. But it was the beginning of 50 years ago, and now we are evolving to these new pocket labs in this system. And of course, when we need more power, we need more multiple users, we need more users working, we can go to two different approaches. One is the farm lab. You put different parallel systems, and every user will start to connect to one of them, and having the use of one for the alone use of this user. Or we can have federated labs, as we have in the pillar, where we put different multiple VSIRs working together, and then you can have load balancing, and the people can go to one place to other place in the one that is from Spain in Madrid, or Bilbao, or Porto in Portugal, and you can do this kind of thing. This is a way to increase and multiply the effects of the remote labs. The major part of the pros of a remote lab is that it's the same component and the same use that you have in a hands-on lab. And the cons of the remote labs normally is the maintenance, and normally is they should be a single user environment there, and you have to make some sharing activities there. How we are evolving this kind of information from the remote labs? Of course, we can go to the MOOCs. MOOCs was a new learning activity. They have around 15 to 20 years old, the first MOOC. The growing of the MOOCs was from the 15 to today in the world. And we developed 7 or 8 years ago our first MOOC using a remote lab inside it. We put a VCR system. This is the characteristics of the VCR systems. And we put a new MOOC, and you can do practical activities using, in this case, basic of circular practical electronics using a remote lab. This was the way to approach people that never touched a real electronics laboratory to have at least a sensation of the use of the remote laboratory in this case. We didn't put here real theory basis for the electronics. We put mainly was oriented to do the practical activities with the remote laboratory test. And we would do, in this case, a MOOL, a massive open online laboratory using this kind of things. We developed several videos, several activities from the typical whiteboard having interaction between the teacher and the environment and the VCR, making some different practical and testers there, showing different approaches, different electronic approaches, and having different videos for different people inside the department. We do a lot of activities there. The expected time for doing this MOOC was around 3 months, having from 5 to 10 hours a week, and you can do a lot of different tests like a senior circuit characteristic curve, or you can do it some kind of balancing of the different resistors there, trying to apply things there using the oscilloscope and the activities there. We have a lot of users. We have in one of the goals, we have the runs, we have 2,600 people. In other one, we have 3,300 people there. Around 7,000 to 8,000 people goes using these systems. And we have, for example, some of the relais of the VCR systems has more than 500,000 of activities in this period of the MOOCs there. We have 4 runs and we have 2 years of working in this MOOC. And of course, the people that finishes all the courses are really slow. For example, we have a typical ending time of 5 to 10% of the people finishing. And we used to this MOOC as a spook, as a small private online courses, because we integrated this MOOC inside our first foundation of electronics engineering there. Last part of the presentation, we talk about the standards. The standards are really important today in the people there. The standards are really necessary for the using in the remote labs. And we are doing inside the IEEE Education Society, we did 2 years ago, we defined the first standard we developed inside Education Society for the networking smart learning objects for online laboratories. The standard is the IEEE 1876 standard. And we talk about the relation, the basic relation between the actuators and the code. This is the part, the level 1, we developing from the service metadata, services, protocols, mainly devoted to sensors, actuators, instruments, controllers, and embedded server computer or microcontrollers. We developed this first level of the standards. This is finishing, and we are now working in another 2 environments, 2 different levels of the standards inside the IEEE Education Society, and in some cases together with other societies of IEEE, like the Industrial Electronic Society. And to finish, I will talk a little bit about the time we are there. In the last year, in the 2020, we was in the pandemic, in the COVID time, when every people was at home, every people was confined at home there, and we have all the education was online. 100% of education was online, and we have a lot of issues there because the teachers are not aware, are not really fluent with the online activities there. Students are not fluent with online activities there, And these kinds will have some kind of back on the online education because the high increase in the last year was really complicated. Of course, now in the 2021, we are in the post-COVID. We are really in the middle of the COVID because a lot of places has confinement there. We have a lot of issues in large countries like India, like States, some part of Europe, in Spain, in my country, we have a lot of issues there this year too. But we have a lot of universities of institutions that are having some face-to-face laboratories. Others have some full face-to-face activities. But in general, not all the people is in the campus today. And now all the universities and all the institutions worldwide are doing some mixing between face-to-face, online activities there because they need to do it there to try to avoid the issues of the pandemic time and trying to avoid the problems in the health there. At the beginning of this period, we have the sensation that I like really much this image because all the teachers and the students must move a lot of weight and a really complicated weight in a cube that is really weighted for them. Today, 1 year after, we are not yet in this position to really have a smooth movement of the ball of the education, but we are more close to these kind of things as we do in the distance education because we have more than 45 years of distance education doing engineering times there. One of the things that is really important is the reliability. As we told, we have to be reliable with the technology. It's really important that the technology will work, like the WebEx connection today, or like the Zoom or Teams connections. We must have a really high quality education. It's important to have quality education. The teaching is really important. The knowledge and the way the teacher communicates the knowledge to the students are really important. We are now in a mixed and a blended time, and we cannot have 1 hour or 2 hours a day of the same subject only with the face-to-face or online activities. Now with the video conferencing of the teacher, we need to change the things. We have to go to blended learning. In this case, we try to have several activities, like to put in a lot of collaboration activities for the students in a standalone or a group activities there. They have to do, in this case, the typical flipped classrooms to try to do activities for the daily activities there inside the time of the classes, and probably for 1 hour class we'll have a 10 minutes presentation by the teacher, 40 minutes of working for the students, and a final 10 minutes presentation for the students of the things they're doing in all the classroom or making some grading there. Evaluation is really important in this kind of things. We have a lot of issues during the pandemic time, the last year, for the online evaluation. Online evaluation is really complicated because it's really complicated to have a real accreditation of the students. We have to continue working in this kind of things, and we have to increase the good part of the evaluation and the accreditation of the evaluation for all the students, for the knowledge and the acquisition of the knowledge there. In this case, I really recommend that the evaluation must be a really good evaluation activities, mainly regarding for the things that the teacher has to do, continuous evaluation, a lot of weak gradings and weak questions and so on there could be part of not only a final evaluation for this kind of things, a final grading. Finally, we have to say that this kind of education has a higher cost. It's really important to have in mind the cost. It's really complicated to manage it because this is a cost of the technology, a cost of the people involved there, and so on. And in some places, there is some kind of cutoffs in the people or in the students' activities there. Okay, thank you very much. We'll finish in this case for the presentations. It was a pleasure to be here. Thank you for the IEEE chapters of the Bangalore in India and the Spanish and Portuguese chapters there. Thank you for the IEEE Spain section, of course, because they was supporting us for this presentation, for this week's webinars. Thank you for the student branch of the IEEE in the UNED. Thank you for the Takapanu UNED chapter New Alpha there too. Thank you for the Portuguese Society of Engineering Education that was supporting us too, for the RIBA University, and finally for the eMadrid Excellence Network for Education. If you have any questions, we can start to answer to these questions there. Thank you very much. Hello. Well, we are starting with the questions. I see the first question from Osvaldo that say that how to evaluate the educational effectiveness of online laboratories. It's really complicated to evaluate, of course, the effectiveness of something there. The only way to do it is to share with the students and the people that is attending how they think about that, making some gradings, and trying to see if they are agree or not with the things they are doing. Of course, the major part of the things must be to have a really good educational activity using the lab, like you have with the real lab, with the hands-on lab, and of course trying to make a survey to see the effectiveness that the students say it. The different kinds of remote, virtual, software labs and the effectiveness normally always depend in the real educational activities that they should be involved there. We have another question here about the challenges to implement remote labs. The main challenge, as I say, is we start from the end to the beginning. The main challenge should be the maintenance. It's really important that the lab, the remote lab, should be really reliable and should be always working. If we like to have, for example, shared the lab in a 365 days a year, 24 hours a day, or if we have only during the time of the teacher classes or something like that. Depending the level of the time that should be available, the reliability and the maintenance that should be higher, and this is the more important thing. Of course, the remote lab and the lab must be really well developed. You must have a really good user interface. You must have the good connection with the lab, of course, and the real lab that you will use it together with the educational activities you will prepare with it. There's one thing there. If you like, Pedro, you can try to say something, but I will unmute you. You didn't have voice, sorry. Okay, we can go there, and Pedro Fonseca is the chapter chair of the Portugal chapter of the IEEE Education Society. One other question is if it should be possible or advisable to have an entire electronics course using remote labs alone. Yes, of course, it's feasible. As I told you, from my point of view, it's better at the beginning of the freshman. If we have a 4 years degree or 3 years degree, at the beginning it's good to have some kind of hands-on lab. And of course, if you are going ahead in the degree, you can have some more hands-on labs, but you can share software labs, virtual labs, simulations, and remote labs together with the hands-on labs. If you have a short course, for example, a 1-month course or 3-month courses, it's much more complicated, these kind of things. Then probably if you don't have access to a lab or the lab is really far for the students, then the only good solution is the remote labs. And of course, if there is no remote lab available, there should be a good solution to use simulation, virtual labs. Everything is in the practical competences. It's like to do some exercises on practical work together with the theory. As much as you do practical work, as much as you have more knowledge in your head there. We have one comment too from Luis Gomez. The level of the remote lab for introductory courses. As I told you, this is in the same way. For the introductory courses, from my point of view, it's better if it's possible to touch real labs there. But if there is not available, remote labs, software labs should be feasible, and anyone should put some part of the competences inside there. Another question is how to access the remote labs. Depending the labs, we will do it. We will have during all the week, we will have several days. For example, tomorrow you will have the IoT and practical laboratories, using in this case BISH as the environment to pack the labs there. And you will see several labs there, and Sergio Martin will put some of the links to the labs to do it there. We will include too, in some moment, we will send you some links to different labs, like the FPGAs and remote education activities there. Some labs provider, labs like Labsland. Labsland is one spin-off of the Deusto University in Bilbao, Spain, and they provide access. They have some part of the access on free. They bring free access to all the labs during the pandemic time, the last year. Now they have some labs with some small cost. They have other labs with no cost, and they have other labs only for institutions. And of course, there should be some part to do it there. Some more questions. Yes, about the standard and the interoperability. Yes, this is really important to do it because all the contributions should be having in mind when you prepare a standard. IEEE has an environment developed, an association, the Standard Association of IEEE, only devoted to the IEEE standards. And IEEE standards are really important because you have, for example, the Wi-Fi standards, the Ethernet standard, a lot of standards that you use day to day are providing from IEEE standards. And this is the way of the interoperability. The industry is really oriented to the standards too. Then we have to integrate, in this case, from the educational remote laboratories, part from the educational activities, part for the industry activities there, and all together they develop the standards that we have to follow to have to develop a real interoperability environment. Other questions is if we have some best practices to improve outcomes. As I told you, from my point of view, and mainly today, was we have some blended learning integrating some lecturers from the teachers together with the online time. From my point of view, today the most important thing is the collaboration. As I told you, the flipped classroom to have collaboration activities there between the students. One students alone, students with students, some peer student review there, and having some presentations to all the full class. I believe this is really important to have this kind of integration of best practice activity on the educational activities there. I'm checking some more questions. We have a lot of things there. One question is to join to remote labs. If they join, they need to join the university to a federation or society. Yes and no, depending the lab. We have a lot of different labs. Some labs are open, then you can use in any moments. VCIR, part of the VCIR lab are open, and you can go to VCIR. You type VCIR UNED, or you type visit UPorto, or visit UDeusto. And then you have a lot of VCIR in the world, and then you can put VCIR remote lab. You can see a lot of information there. Some part of the remote labs are open, other part are really closed, only for students, because we need to maintain some part of the labs devoted to the student activities there. And this is really important there. Or for example, in the case of the Pilar Federation, we have an open group in Pilar Federation inside the IAOE, the International Association of Remote Engineering. And this association, IAOE, develops and integrates a Pilar Federation. The participation in the Pilar Federation is free for each one that they like to do it there. We will send you some information, as well as the participation in the IAOE is free for everyone. If you like to be in the board and to have some voting rights, then you have to pay a small fee. But the general activities there are really free. I will send you later information for the Pilar. I pointed note. Okay, there. Final questions. One is if there is some surveys to regard the effectiveness of online and offline teaching. There is some publications about the effectiveness and surveys. If you read publications like IEEE Education, Transactions on Education, or the Computers on Education publications, and the Journal of Engineering Education, then you can see some really good surveys. They are published there and with results and with the activities they do there. This is part of the archiving materials inside the main journals that we have archiving there. Yes, one more question is that if the students have to spend some time in real labs after completing virtual labs. From my point of view, is really good. As I told you, in my preference is that when you're starting a new courses, if the student has some background in the field, in the practical and hands-on lab, you start a new courses. For example, you start a course in advanced analog electronics with different systems in radio systems or tuning systems or PLLs, some part of the high specialized part of analog electronics. Then you could start with really good simulations, with really good virtual labs if you have from them. And you can use later some LBs with National Instruments and some VCR labs with this part of some different components there, or a lab with FPAA with the field programmable analog array that we will say in the Friday with Alejandro Macho. And after doing these kind of things in virtual or in remote labs, always is really preferable at the end to touch it, because in electronics and in all engineering education, it's really important to touch it. Sometimes it's not possible because this is too expensive or something like that. But if you can have opportunities, of course, it's better to finish any subject having some small one. For example, in UNED, for every subject we have in a semester subject, in electronics, for example, we used to spend from 4 to 5 days of students using virtual simulation and remote labs. And we spend at the end 1 day in a hand-on lab, in a real lab there, because we always have to finish the courses doing this kind of real labs there. And this is all the questions we have. Thank you again for the time there. Thank you, Siva. Thank you all for all the attendees people there. Nice to see you, and see you tomorrow in the next presentation of this webinar series. Bye-bye.